Okay, so for 47.3, we're going to talk about the variation in the electrical conductivity of the elements across the period. So for the electrical conductor, you should remember that, okay, they must contain delocalized electrons or mobile ion. But right now you know that we are talking about elements, so therefore mobile ion actually is not really applicable. Okay, so most of the time we'll just see that whether they contain delocalized electrons or not. Okay, so for the variations, actually it's pretty simple. You find that, okay, the giant metallic structures, you must know that they have delocalized electron. While for the giant covalent structure one, except graphite, other than that, all of them, the atoms are held together by by covalent bonds. So therefore, you'll find that this one normally they don't have the localized electrons. While the last one, simple molecular structures, again, okay, they do not have the localized electron as well. So you can see that the electrical conductivity, they will have mainly or focus on the giant metallic structures to have electrical conductivity, while for the rest of them they should have no electrical conductivity. Okay, so for the train, okay, remember you need to plot a graph like this, okay, just like previous one. So before we move on, okay, I want you to focus on the y-axis. Okay, that will be the relative electrical conductivity. The highest one will be 1, the lowest one will be 0. That means if it is an insulator, that will be 0, insulator. If it is a very good conductor, that will be 1, okay? So relatively to each other only, so that we just have the shape of the curve will be all right, okay? So for lithium and beryllium, you see that these two are the giant metallic structure. We also have like sodium, magnesium, and aluminium. So you can see that they will have different electrical conductivity. Actually, it's very easy for you to make a guess. That would be depends on the number of the localized electron participating in the metallic bond. So for aluminium, we got 3 electron. Magnesium we got 2, sodium we got 1, okay, beryllium we got 2, lithium we got 1. So therefore, more delocalized electron participating into in the metallic bond, the higher the electrical conductivity that will be. And for the rest of them, they don't have delocalized electrons, so therefore that will be relatively low. Just want to draw your attention to this one. Okay, silicon actually is a giant covalent structure, but at the same time this is a semi-metal. So for semi-metal, actually they will be slightly conduct electricity in normal condition. The electrical conductivity will be even better if it is at a higher temperature, because the mechanism like conducting electricity will be slightly different from a normal metal. So in short, you'll find that giant metallic structures, the electrical conductivity increases with the number of the localized electrons participating in the metallic bond. So in general, group 3 will be stronger than group 2, will be stronger than group 1, because group 3 will have more delocalized electrons than group 1. For giant covalent structure, normally they will have no delocalized electrons or mobile ion. Okay, so therefore they will have 0 electrical conductivity. But just mentioned just now, okay, silicon is a semi-metal, so they have very few delocalized electrons and not a good conductor at room temperature. However, if it is a higher temperature, you will find that they will become a good conductor of electricity. So we call that one a semiconductor. Last one is simple molecular structures. Okay, again, no delocalized electrons or mobile ion. So therefore, they cannot conduct electricity. So some examples, okay, you can find 47.2. So sketch the trend, okay? So when you sketch the trend, okay, so first of all, you have to remember the vertical axis, okay, the label of it, okay, so you will have a relative electrical conductivity. You have to write the full form, okay, just write shorten it, okay. Then if you are required to talk about 3 elements, okay, so you put a symbol like this, okay, so you can like the textbook, okay, you just draw the trend like this way, but I prefer that would be better is like this one, okay, so just going up, okay, would be all right. You put cross, okay, up I don't mean it have to be a straight line. Okay, don't misunderstand me. Okay, I'm just talking about there is a cross would be better. Okay, so a cross, a cross, a cross. Okay, so you do like that would be all right. Okay, so you don't necessary. It is not necessary for you to remember it's a straight line or just going like that way, straight line, or going like that. Okay, it's not necessary. Just show that the trend is going up will be all right. Okay, so next we're going to explain the trend, okay, in terms of bonding and structure. So you can see the structure. First of all, you talk about the giant metallic structure. Okay, they are very good electrical conductivity, so good conductor. So the bonding, okay, that will be related to the metallic bond, and why that will have an increase, okay, in the electrical conductivity. You have to talk about the number of outermost shell electrons increases with the atomic number. The larger atomic number, the more outermost shell electrons can be shared, so therefore electrical conductivity will then increases, okay, from sodium to aluminum, things like that. Okay, so that will be pretty easy. Okay, and then next, okay, that will be the class practice similar to that. Okay, we are talking about period 2. Okay, across period 2 we have like lithium, beryllium, and then for the rest, okay, they should be non-conductor. Okay, so again, so you have lithium. Remember, you are on the x-axis. Okay, you label all of the element like this, one by one. Okay, and then okay, you put cross for the data. Okay, so lithium and beryllium contain 2 electrons, lithium contain 1 electron in the outermost shell only. So therefore, you see a rise right there. Okay, and then going down to heating 0. Remember, must be aligned with the x-axis. Okay, must be 0. Okay, so the y axis, okay, that would be relative electrical conductivity. Last one, we're going to explain the chain. Okay, so like what we've done previously, you will be mentioned lithium, beryllium. They are their metals. The beryllium have more delocalized electron than the lithium, so therefore the electrical conductivity will be higher than that of lithium. While for boron no delocalized electron, and then for carbon, nitrogen, oxygen, fluorine, neon, all these things, they are non-metal. They do not have delocalized electron as well. That's it easy. Okay, so that's all for this part. Okay, conclusion. Electrical conductivity increases with the number of delocalized electrons participating in a metallic bond. So in general, will be group 3 will be stronger than group 1, while the other two, they do not have delocalized electron or mobile ions. Okay, or mobile ions, so therefore they cannot conduct electricity. And most important part for this section will be sketch the trend and remember the y-axis. Okay, that will be the relative electrical conductivity. That's all for this video. Bye bye.